Good morning, everybody, and welcome back to Next Door NetAdmin. Today I'm going to talk about something that's really kind of complicated, and it's a bit of a mind bender. But try and stick with me if you want, and if not, go ahead and watch something else. But I'm going to talk about and try to illustrate the message flow of onion routing. Onion routing. What is this? Onion routing is a technique where you take a message and you wrap it in several layers such that it goes through many different points on the way to its destination. No point in the path can see anything except the layer above and the layer below. So you can send a message and have it bounce along the internet, essentially, until it reaches the final destination, and no point knows exactly where it's coming from or where it's going to, with a couple of exceptions. Obviously, the first node in the path knows where it's coming from, and the last node in the path knows where it's going to. But otherwise, there's no complete record of where the message came from and where it's going to. This is a technique that was developed a long while ago, partly with the sponsorship of the US Navy, fun fact. And it's useful for essentially bypassing censorship. If you are in a place where you have a government, let's say, that is very restrictive on what its citizens are allowed to read or not allowed to read, techniques like this help bypass those censorship regimes and allow freer access to information. So, definitely something that is useful for a network admin to know about, but it is very complicated. It's not so complicated to use these days because the tools automate a lot of this. But for a network admin, understanding exactly how this works is an interesting thought puzzle and an interesting exercise to see if you can wrap your head around. Now, this partly depends on knowledge of public-private key cryptography, asymmetric cryptography. And I've done a video on that in the past. So if you want, go ahead and look back at when I was talking about public and private keys. The key point, to understand about this is that what one key does, the other key undoes. And it goes both ways. The public key is just the half that's made public, and the private key is the half that's kept private, oddly enough. But what the public key encrypts, only the private key can decrypt. And what the private key encrypts, only the public key can decrypt. So, cool. Let's talk about a bunch of nodes. The source node is Lime. That's me. In fact, I've written it out here with a bunch of keys so we can take a look at this. I'm Lime right here at the top, and I want to get a message over to Red. And where I have written public and private, okay, public is the part that's available for anybody to know. Private, I'm going to keep for myself. And over here, for Red, I don't know Red's private key. I've only written it down here for the sake of illustration, but I don't know Red's private key, just the public key. Okay, so then I've decided, okay, so I see a bunch of nodes in this circuit, nodes that are available for me to build a circuit, and I've decided that I'm going to relay my message to Red via peach, green, and blue. And I know their public keys. I don't know their private keys. I don't need to know their private keys. But then, Lime, myself, has also created a bunch of message keys. And I've created all of these keys, so I know what the private portion is, and I know what the public portion is. That's going to be important in just a minute. So I've got some of these keys here, and we'll see this sheet again as we go. So the first thing I want to do is I'm sending a message to red, right? So here's a message. It just says message. And I'm including some instructions to tell red how to reply to me. Because I am going through peach, green, and blue, that means that red needs to reply to blue. And I've told it to encrypt the reply to the public key of AAAA, which, if you'll remember, that's my public key. And I have the private half that can decrypt that. Cool. So then I take this message and I seal it up. And on the front of it, I say it's to red, and it's encrypted with red's public key. Right here. It's encrypted to 1111. So only red can decrypt this now. Only red can open this because only red has the private key for it. So then I want to put this into the next node in the path to blue. And I'm going to include some instructions for blue. Send the reply via green, because that's the next node in the path. And encrypt your reply to VVVV. That is one of our message keys, the message key that I've created for blue. This is just the public key. It's not the private key. I'm keeping the private key for myself so that me, Lime, is the only one who can decrypt it. Cool. So I'm going to take this message to red, and I'm going to fold it up and put it inside the message to blue. And it's encrypted, oopsie, with blue's public key. GGGG. So now only blue can unpackage this to see that the next stage is to go to red. Nobody else knows that. Okay. Next stage in the path is green. Here's some instructions to green. Send your reply via peach and encrypt it to XXXX. That is the public key that I created for green, and the private key is mine. I'm not giving that away. Cool. And then I'm going to take this and I'm going to include my message to blue, which includes the message to red. And now we have it like this. And this is encrypted using green's public key, EEEE. Now only green can unpackage this, but green can only unpackage its own layer to see that the next stage is blue. It can't decrypt blue's part. All right. Last stage in this path. Okay, peach. So here's the instructions to peach. Send your reply via lime, because, you know, theoretically, lime could have received this from somebody else. So send your reply via lime and encrypt it to your key, your public key of ZZZZ. And again, I'm the only one who can decrypt this because I'm keeping the private key for myself. All right, so then we package the rest of our messages up so that when we send it to Peach, it's encrypted using Peach's public key, CCCC. Only Peach can decrypt this. So now I've put together a full message. It's going through 3 different nodes, peach, green, and blue, in order to get to red. But I've had to put in 4 separate messages, and each time I've wrapped it up in a layer going to the other one. So I send this to Peach. Peach can decrypt this because it has the public key, the private key for that. And it sees that the next stage is to green. Peach can't open any of this, but Peach says, okay, so I've opened this. I'm going to keep this so that I know where the reply goes to and how to encrypt it. Fine. So it goes to green. Green can decrypt this layer. Green keeps the reply instructions. Okay, that's fine. Put that down there. Now it's going to blue. Green can send it to blue. Blue has the private key for this, so blue can decrypt it, save the reply instructions, all right. And then the final stage says send this to red. Blue sends it to red. Red can do the final decryption on this packet in order to reveal the message. And it says send the reply via blue and encrypt it to this. Okay, so that's what red's gonna do. Here we go again. Red is going to say, okay, well, I'm supposed to send this reply via blue. So here we are. Here's the response. Send it via blue, encrypt it to AAAA. All right, here's the response. It's going to blue, but it's encrypted using AAAA. Blue doesn't know what AAAA is. It has no idea, because this blue AAAA, this AAAA key is actually mine, my public key for Lime. But it doesn't know that. All it knows is that it's encrypted using a key that it can't decrypt. These are really short keys, and it would be easy to look it up. In reality, these messages don't say which key they're encrypted with. So you have no way to know that this is encrypted using AAAA, because that would make it really easy to look it up and say, okay, well, who has that key? It's Lime. Not so much, but I'm putting which key it's encrypted with for the sake of illustration. So this is to blue, but this is a message that it can't decrypt. It can't open this and see what the response is. But blue knows that its reply is supposed to be sent via green, and it's supposed to be encrypted using a key VVVV. All right, so let's do that then. Let's get the next layer, which is green. Green, there we go. And we're going to do the same thing, essentially. And we're going to wrap the response that was sent to blue, which it can't open, it doesn't know how, and it's going to send it to green, encrypted with VVVV. Again, green doesn't know what that is. Green doesn't have that key. I have that key. Okay. And I'm just realizing now that I think I've done that incorrectly. No, I didn't. Because this is from blue, and it's encrypted using VVVV. That's correct. I planned this all out ahead, but like I said, this is complicated, and I start to confuse myself too. Right, so this is being sent to green. When green gets it, green has no idea how to decrypt this key, because it doesn't have a matching key for that. But green does have the instructions that say, send the reply via peach and encrypt it using XXXX. Okay. We can do that. We can send the reply via peach, and we will just take this entire thing, wrap it up just like we did before. Now we have one to peach that is encrypted using the key XXXX. Okay, but again, this doesn't match what peach has. All right, fine. Well, peach has the instructions that say, send the reply, this reply, send it via Lime and encrypt it using the key ZZZZ. Okay, peach says, all right, I have no idea where this is going or how far, along the line we are. All I know is that I'm supposed to send this to Lime using the key ZZZZ. So this is the reply that comes back to me All right. I actually created all of these keys so I can decrypt this. I know that the matching private key for ZZZZ is YYYY, so I can take that layer off. I know that the corresponding private key to XXXX is WWWW, and I can take that layer off. I know that the private key that matches this is UUUU, so I can take that layer off. And finally, I have my public key is AAAA and my private key is BBBB. So I can also decrypt this final layer, and I can get the response right there. Response. Cool. This is massively complicated. Yes, absolutely. But fortunately, we don't have to remember all of those steps, and we don't have to manually remember all of those keys. We have tools these days that allow us to simply open a browser, essentially, and all of this stuff happens in the background. There's a program called Tor. It stands for The Onion Router. Fairly well known. The nodes, all of these nodes in the middle, for example, in our example that I've done here, peach, green, and blue, those are all run by volunteers. And the beauty of the system is it doesn't matter whether you trust the volunteers or not. Generally speaking, you want to be able to trust them to, not modify the code and do nasty things with the traffic. But ultimately, on some level, it really doesn't matter because of the layered encryption. This packet that I originally sent to Peach, and it was to go through Peach, green, blue, and then end up at red, Peach doesn't know where it's going, other than it's coming from Lime and it's going to green. Peach doesn't know if I'm the actual originator of that message. I could have, unwrapped another layer previously and just be relaying something along. And red doesn't know who it's sending it to. It only knows who it's sending by and what key it's supposed to encrypt it to. So green might not be trustworthy at all, but green can only see it's coming from Peach. It can only unwrap its layer and then send it on to blue. The message is still going to be safe. And it's the same on the way back. Blue got a message from red encrypted using a key that it doesn't know. And it can't do anything about that. All it can do is accept the message and follow the return instructions to encrypt it to a different key entirely and then send it to green. And only after it comes all the way back to me, the originator of the message, or to whoever else originated it, only the intended recipient can unwrap all of those layers that have been reassembled as it went through the network. So here's the transmitted message from Lime to red. Here's the response from red back to Lime. I start by creating all the layers, and what I get back also has all the layers, and I have to unwrap all of them in order to actually receive the message. So if you are using something like Tor, there's a bundle, the Tor browser bundle. It does all of that for you. It picks out the nodes that you're relaying the information through, and it handles wrapping it all to send your message, and it handles unwrapping it all when you receive your message. But onion routing is a very powerful technique. It's also been used for email in the past. There was Mixmaster and Mixminion and other. There's type 1, 2, and 3 remailers. One was a cypherpunk. The original cypherpunk remailers were just essentially you'd wrap your message and send it. each hop along the way might remove a layer and send it on, but there wasn't any way to send back. Okay, fine. So that was cypherpunk. And I don't remember the difference between Mixmaster and Mixminion, but those were additional remailer types that were out there for a little while. Not so many of those out there these days, quite honestly, partly because email is one of the hardest things that you can do. And for gathering information, it's been more important to have a browser, particularly when you have forums or other sites, some including those that are actually located within the Onion network, so that it doesn't end up going to a server on the public internet at all. So there are other ways that you can pass messages these days, but the concept of onion routing was also definitely used in email. And it's still a very foundational concept in message anonymity. And yes, to some extent, that has also been called the dark web, because it's kind of difficult for a lot of people to get into, and it's difficult to understand what you're doing. Some people would say that's, only in use for criminal activities. It's a tool. Like any other tool, you can use a gun to hunt game. You can use a gun to kill people. The gun itself is neither good nor bad. In this case, these techniques can also be used for good or bad. Yes, criminals can use them. They often find it a little difficult, just like everybody else. And there's still lots of ways to catch criminals, even when they're trying to use the dark web, because they make mistakes, same as anybody else. But it's also used, like I said, to bypass censorship regimes, whether that's in China or Iran or Turkey or any other place where government has decided to get involved in telling you what you can and cannot access. Sometimes this might be the only way, or one of the only ways, that you can get accurate information regardless of what the people in charge are telling you. So it's a valuable technique to know, and it is one that I would encourage admins to be aware of and look into, particularly if you're kind of the geeky sort that likes, codes and ciphers and all the rest. You can get lost in this stuff. And how? Because I've done it. But yeah, there you go. A little bit of a demonstration on onion routing and how that works. Hopefully that was interesting to you and useful and enlightening and all the rest. If you have thoughts on other things that you would like to hear me talk about, or things that you would like to see me demonstrate, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.